Hello, my name is Lara Law, and this is my 3.2 HD research report and presentation. It's called Origins of SQL, MySQL, NoSQL databases, and the integration of DBaaS, which is Database as a Service. So let's begin. Let's start to understand what this is all about. So I've delved into the origins of computing from the perspective of SQL. And SQL is a structured query language. It's a programming language. Then you've got MySQL and NoSQL. These are databases. And then you've got DBaaS, Database as a Service. And this is a managed cloud-based service. Then I've had a look at the type of databases there are for NoSQL. There is a term called polyglot persistence. It means that there's multiple types of databases or data storage technologies with a single application or system. It's basically choosing the best database for the job. So let's have a look at some of the history as I've gone into. Firstly, we've got Edgar F. Codd. He wrote in 1970 about relational databases and the model to do with it. He stated that the usage of large databanks must be protected from having to know how the data is organized in the machine. What he meant by that was the abstraction principle. It's a term used in computer science, and it's the idea of hiding complex details and only showing the essential parts to the user. This was the underlying principle of what Codd was meaning and what the SQL relational data model theory is based on. My research report, as I said, it covers some history of computing. So I started with the mainframes. I looked at the invention of the tabulating machine, which was invented in 1890. It had a system of using punch cards with electromagnetism, and it was able to calculate up to 63 million US census people. It was an amazing invention, and this also led to the creation of IBM years later by the merging of three companies, including the inventors of the tabulating machine company. But years later, developers were becoming frustrated with SQL. It had some limitations, and so they had a conference, they had a meetup in 2009. They didn't want to reject SQL entirely, so NoSQL was a bit misleading. But what they mean by that is not only SQL. So this was to help with managing non-relational databases, because SQL is the language, but MySQL is the relational database. So this meant some advantages. Finally, I was looking at the integration of the database as a service. It has helped take NoSQL to another level of global reach. It's enabled the system to handle large volumes of data associated with the use of real-time analytics, chat, messaging, and Internet of Things, as well as sensor data, things that have all come about as the Internet and the web have got bigger and bigger and populated and made into a very popular user experience. So let's have a look now at some of the timelines that I have. So here we have, in 1950 to 60s, we had mainframes dominating. There were punch cards, there were data in tapes, but no personal computer. In 1968, IBM invented the information management system, but it was a hierarchical database system. So it had like a parent with children. And so you had to know with pointers exactly the structure of the database and what the parent name and structure was. Otherwise, you wouldn't be able to find the information. In 1970, Codd published the paper, The Relational Database Model, which discussed the relational data model. And so then we had from 1974 to 1979, SQL and System R was released at IBM. This was based on Codd's work. And Oracle released its first commercial SQL database. There are other things there that have come to note. You've got in 1989 the Lotus Notes, a document-based database release. Then in 1991 there was a Berkeley database, an embedded key value storage database. 2003 to 2006 you had the Google Bidable and Amazon Dynamo NoSQL-like systems emerged. In 2009, Johan Åkesson popularized NoSQL. He had the first conference in San Francisco, and after that, it became to be the most popular of the NoSQL. It became mainstream essentially a year later, and the platforms such as MongoDB, Cassandra, Redis, Couchbase NoSQL databases became popular. So let's keep scrolling through these and let's have a look at something else. I've listed here some NoSQL advantages, things that are good, and also a couple of disadvantages. So here we go. NoSQL was created as a reaction, as I said, to SQL's limitations around scale and agility. SQL remains a core to the data integrity, structure, and analytics. But NoSQL isn't anti-relational. It's non-relational, choosing performance and flexibility over strict normalization and relational theory. Choosing a database for the right job, using a mixture of MySQL, NoSQL, and DBAS solutions. This is called polyglot persistence. NoSQL database is denormalized. All related data is stored together. NoSQL benefits are there are faster read times and there are limited joins because joins take up runtime and memory. NoSQL disadvantages is that there can be data duplications and it can be harder to update all the copies. So, NoSQL, it has flexible schema, it has a handle of large volumes of data, and it has horizontal scalability. Let's have a look at the next slide. NoSQL, its best uses in today's society. It helps in regards to social media. It stores things like user feeds, likes and comments. It also does e-commerce. It helps with shopping carts and product catalogs. It stores all this information. IoT, Internet of Things. It helps in regards to devices such as sensor readings and smart devices. Real-time messaging with WhatsApp and Discord, just to name a few. Businesses also use NoSQL, of course they do, but some big businesses like Netflix and Amazon. Let's have a look what else there is. We've got types of databases, types of non-SQL databases. Now, we've got document-based ones that store data as documents. Key value, they store simple key value pairs. You've got column family, which stores data in columns instead of rows. Group-based, it stores data in nodes or entities, and edges, relationships. MySQL, the limited and the advantages. There's so many, but mainly there are advantages. So you can say that the limitations of MySQL are that the schema is fixed and predefined, and the only way of scalability is vertical, which means adding more CPU and RAM. The advantages are that it has data integrity and relationships which enforced the constraints. It has standardized programming and is supported by many RDBMS systems, which is relational database management system. With a NoSQL, it has a flexible schema. It allows for storing of data without the strict structure. You have certain file types like JSON, which is a JavaScript object notation, or you've got BSON, which is a binary version, which doesn't have as much memory to store because it's in a binary form. Then with the database as a service, the limitations are you don't have the full control over the database. And for small to medium enterprises, it's cost effective. But for larger organizations, it can become expensive and it can be better to do it in-house and be self-managed. However, the advantages is that it can help with working with those NoSQL systems. It can provide a broader global market for the NoSQL, and it handles especially high volume applications, real-time analytics, chat, messaging, and Internet of Things, and sensor data. So there's a lot of interesting things that you can learn about MySQL, NoSQL, SQL, the programming language, and database as a service. I hope you've enjoyed this presentation, and I hope you have a great day. Catch you later, and bye for now.